Well, good morning. My name is Arun Gupta. I am one of the principal open source technologists at Amazon. Today, I'm very excited to have Sam talk about microservices on AWS. Sam is definitely one of the subject matter experts on this topic, and he brings that unique perspective from the community side of it on what microservices are, what are the different AWS offerings on it, and how can you build your microservices. Sam is going to be running most of the show today, but towards the end of the talk, we will have a Q&A between him and I, and hopefully that will be a lot of fun and interactive discussion. All right, Sam, take it away.
Thanks, mate. Okay, so I'm going to keep my volume light. If for any reason at any stage you can't hear me, just wave your hands and just hope it's not a point where I'm pausing, because then that's going to get really confusing. But thank you so much for coming along today. It's my first time in Vegas. I say that it's not entirely truthful. I used to live up in San Francisco. I drove through Vegas very fast a couple of times. We never stopped. Mostly because it's like where are you going to stop on the strip? So we just drove through. So I have been through. It's my first time in Vegas. It is insane. I'll leave it at that. I hope you're enjoying the event so far. I am here to talk to you today about microservices I'm going to talk very briefly about what they are, and then I'm going to try and sort of talk about the ethos behind both microservices and the whole AWS experience, really, and show how these two things work really well together. And then I'm going to take you through a few options about how you might deploy a microservice solution on AWS, and try and give you some of my sense of where I would be looking and investing. And we'll even talk about serverless, because we have to talk about serverless, even though this is technically the containers track. But we should push on. I wrote a book about microservices a couple of years ago. I'm in the process of working on a second edition. If you've read the book, that's great. The second edition won't be out for a while, so you should still go read it. I've also been lucky enough to be working with Amazon Web Services for quite a long time. Sort of by accident, I ended up helping create the first ever public courses for AWS back in 2009. It was purely being in the right place at the right time. So these two things have been a big part of my sort of almost last decade of my career, and it's been interesting in this talk trying to really bring these two strands together and see how they lap up. I now also work for my own company doing consulting and training and all those sorts of things. It's sort of named after myself because I'm a narcissist. But we are here to talk about microservices, so I should do a very, very quick explanation as to what microservices are, just at least from my definition, because there are different definitions out there. This is what a microservice architecture looks like, a quite simple one. I draw them as hexagons because if you spend all of your time looking at architecture diagrams, rectangles get really boring, and this is a nicer shape, all right? We got names, invoicing, shipping, customer service. There is this idea that we use business domains for how we find the boundaries for our services. I'm not going to go into why. You can read the book more or talk to me afterwards about that. Maybe not the most important thing for today, but as a definition, this is what I talk about a microservice being. It's an independently deployable services that work together, modeled around a business domain. We're going to focus a lot on this idea of independent deployability because it's the key thing that drives a lot of what we see and perceive as the benefits of a microservice architecture. We do, of course, have to address the fact that microservices continue to ride high in the Gartner hype cycle. Here they are right at the top, which I think means good. I haven't yet worked out how that directly translates into money in my bank account, but we're working on that one at the moment. I also always find it quite interesting. We're up there, there's microservices all the way up there, and we see down in the trough of disillusionment, we see service-oriented architecture, which I always find to be quite funny because microservices are just a type of service-oriented architecture. So in many ways, this is the Gartner hype cycle, this is more the Gartner marketing term hype cycle, because really microservices are just an opinionated form of service-oriented architecture. It's sort of interesting to note, way back in the day, both Google and Netflix would talk about their architecture as being service-oriented architecture. Adrian Cockcroft, who now is, of course, working at AWS, when he was the cloud architect at Netflix, he referred to their architecture as being fine-grained service-oriented architecture. Now we sort of just use microservices as the term for that. So don't worry too much about those definitions, but if people say that SOA and microservices are different things, they're just wrong, and that's okay. Just get them to buy my book, or like 5 copies of my book. That would really, really help me out. It's Christmas. Won't somebody please think of the children? So back on this, so independently deployable services that work together, modeled around a business domain. That's a definition I use, and this is the thing I want to focus on for today, and actually is the most important characteristic of microservices, and in fact the thing I think you need to optimize for when building these architectures: independent deployability. You should be able to make a change to a service and deploy that service with a new change into production without having to redeploy or change anything else. This means letting go of the idea of lockstep releases. This is all about independent autonomy and independent replaceability of components. And this maybe in one way is how microservices are different to traditional SOA architectures, in as much as this is very much what we're trying to focus on. This is what we're very opinionated about. This ability to make changes to services and deploy them independent of other changes is what gives them their power. Autonomy is the word. We keep coming back to it in many different spheres. It gets talked about a lot in the context of microservices. Autonomy is all about reducing coordination and allowing people to work autonomously from others, reducing coordination, allowing them to go quickly so we can ship software more quickly. So I'm going to ask you, actually, how many people in this room here, how many people here ship to production maybe once a month or more? Okay. So probably I'd say about 20% of the room. That's still pretty good, right? If I asked that same question 5 years ago, I would have got 1 or 2 people. And 10 years ago, people would be shouting, "It's not possible, what are you talking about, are you crazy?" We exist in a world now where we expect to be able to ship software to our customers more quickly because that's what they expect, it's what we expect of the software. And to achieve that, a lot of it is about improving the autonomy of our teams. When we think about a team, right, you've got a few people in that team, we have to communicate with each other, we have to coordinate to be on the same page, right? 3 people, you can kind of mathematically think of it, okay, we've got 3 communication pathways of how we're going to chat to each other. Okay, that's not too bad. We can stay on the same page and be aligned. We add a 4th person, that's only 1 more person. Okay, well now we've got like 6 communication pathways between those individuals. We add another person. Okay, now we've got like 10 communication pathways. I'm going to get the maths wrong. I stop at this number of people because the transitions get really complicated. But we all know intrinsically that as we add more and more people to the same problem, as we add more and more people into a team, coordinating, communicating becomes more of a challenge. Avoiding stepping on each other's toes becomes more and more difficult. If anyone here has tried to have 200 people all working on the same code base, you will know it's not a fun experience, and an inordinate amount of your time goes into efforts to avoid people getting in each other's ways. I'm not the only person to have spotted this problem. Somebody a few years ago said, no, communication is terrible. This was Jeff Bezos a few years ago when some managers were talking about how they could improve communication between teams. He said, no, we want to eliminate, or not eliminate, but reduce communication. What he was actually referring to is the fact that when you have to communicate and coordinate with other people, that slows you down. We've got to schedule a meeting to have a chat to come up with an agreement. Now, there are areas where you need to do that, but what you're trying to do is limit how many of those places you do it in. Now, when you've got 200 people, 400 people, 1,000 people, all trying to coordinate around the same thing, you have lots of points of coordination, and those slow you down. And so this is really why Amazon early on started looking at a model of having smaller autonomous teams. The idea being that a team working on a problem would just have fine-grained communication within that team, but much more coarse-grained coordination with other teams. It's about finding that sweet spot of a small team that can work really closely together and can afford to have that fine-grained communication without requiring loads and loads of coordination. So some of you may have heard of Steve Egge. He moved from Amazon to Google, and he wrote what became known as his infamous platforms rant at Google. It's now become public. And what he was doing in this memo was trying to articulate what it was that Amazon did that Google wasn't doing at the time in terms of how they thought about service design, trying to distill down how Amazon was thinking about creating software. And so he was sort of pulling out the mantras that were being used at that time in terms of how Amazon software should be built and evolved. And saying things like this, all teams will henceforth expose their data and functionality through service interfaces. So talking about the idea that services should communicate through service interfaces, which makes sense, otherwise they're not services, you would argue. And teams must communicate with each other through these interfaces. So sort of now talking about the human aspects, not just the software aspects, not just how does my software talk to your software, but how does my team talk to your team? This is actually aligning the communication pathways of your organization along your architectural pathways. This is Conway's law. So we think about a team working on a problem, a team that could probably co-located or can afford lots of tight, fine-grained communication. They're working within that service boundary. The communication they have with other teams is along those boundaries with those other teams. This is, around APIs, your message formats. This is your coordination points. This is coarse-grained communication and coordination around the same API points. And this becomes a really powerful idea of bringing these two things together. And Steve Egge was reflecting on the fact that this was one of the techniques that Amazon were sort of using to allow these sort of two pizza autonomous teams to go fast, but still coordinate with other people without having all the downsides of being a large organization. You start getting little soft things that actually crop up in the Amazon, the AWS stack that help achieve this sort of autonomy. And it actually starts for me way back with accounts. This was one of the things I remember back in 2009, we were hammering home for people, use different accounts. It's not just from a security point of view, it's not just from a tracking point of view, but it is from an autonomy point of view. That unit of control that you're given, there's a building block of autonomy that's right there in the AWS product stack. Here's another quote from his rant. There will be no form of inter-process communication allowed. No direct linking, no direct reads of another team's data store. Some people's ears prick up at this point. No shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over network service interfaces. Now, practically, in terms of how we interpret that, what that means is something like this. I've got my service. My service is storing some information in a database. And if somebody wants information that I have, they should come and talk to me, right? So here's an outside party. But obviously what we do a lot of the time, and I've seen this over and over again, it's probably the single most common service integration pattern I see, is the other service just reaches straight into your database and grabs what it needs, right? This is going against what Steve was talking about. This is bypassing these well-defined service boundaries. And this is problematic on two levels. Firstly, it's like if you have a well-defined service interface, which represents how you communicate with somebody else, that service interface also becomes the point of coordination between you and the other team. It's actually quite well defined and well observed. If you allow other parties to sort of just reach in around and go through your back door, it's like you've got a nice front door, it's got like a security intercom system, and you greet people in and you offer them iced tea, and then you find someone's broken in your back gate and they're rummaging around in your gardens and they're knocking over the gnome. Right, it gets problematic, right? So you start bypassing those service interfaces and the communication and coordination becomes much more problematic. It's also because databases are actually quite annoying to try and make consistent between releases. So, based on what Steve was telling us, and this is one of the big mantras in my book, it's always coming back to this idea, is if you want data or information, you go and ask the service. The service then decides how it extracts that. See your data storage as internal implementation detail, not an external API. So logically, we can start thinking of our services as being a box, a black box that has a service interface. And if we have a data store that's required inside that, that's an internal implementation concern. A nice thing with the AWS stack is, again, a very simple primitive that we're provided is the ability to deny external access to other things. Could be other accounts or other entities and other security groups. So for example, if I don't want people reaching straight into my database, well, I could just use a VPC to just turn off access to those parts of my system. Enforcing that constraint, it's actually a good thing to make things that are bad, make them hard, right? Don't make them easy, okay? And we get that little low-level building block. Ultimately, we come back to this idea that microservices are an architecture which optimizes around autonomy. This comes all the way back to, well, what do we need to do that? What are the building blocks we need to achieve autonomy? Back when Amazon were creating these autonomous teams, they had the problem, well, we want a small team, we don't want a big team, we want a small team. Small teams can coordinate, they can go fast. And we want to reduce the need for those teams to go and raise tickets with other people. They don't have to ask other people to do things. They want to do things themselves. But they need to deploy things. So do they have to go and buy the machines and rack those boxes up? Now, we could go and get people with those skills and add them to our team. But now suddenly our small team now is a big team because it's got loads of people with different expertise. So instead, they said, well, we can't have our team spending all their time racking up boxes, and we don't want our small teams to become big teams. So we need to improve things, though, where this isn't required. So almost Amazon said, well, we need tools that allow us to self-service provision what we need. So we need to improve our autonomy through a mindset of self-service. And this is what's led to, ultimately, why we're all here, right? The need for Amazon internally to create tools to support autonomous teams resulted ultimately in the development of the AWS product suite, creating higher order abstractions over sort of the big three issues in infrastructure, storage, compute, and networking. This is what we talked about as infrastructure as a service. This is all about empowering autonomous teams to self-service what they need. It's sort of really interesting to me to think that we've had this sort of stuff has come full circle in a way. Amazon wanted to have small autonomous teams, so had to create software to support those autonomous teams and allow them to reduce the coordination, allow them to increase their autonomy, which in turn provided things for other people to also do more of the same thing. Amazon are far from the only people that have done this, of course. We will get to use AWS. Likewise, we think about an organization like Google. So Google, who developed their Borg platform for running and managing large-scale applications at Google themselves, right? So teams can use Borg to deploy their software, and it manages it at scale. If you're interested in the dark details of how this is done, I can thoroughly recommend this paper. If you hang out in these sorts of spaces, it's really well written, and it goes into a lot of information about how this works. And the Borg paper inspired a lot of other platforms like Mesos, which you may have heard of. Now, Borg was an internal product, just like the precursors were to the AWS product suite. And just like Amazon, Google thought, well, let's get these ideas out into the open as well. They took a different route, and of course, what the ideas and the abstractions behind Borg became Kubernetes. We're going to come back to Kubernetes and the other stuff that Amazon's doing in the space a bit later on. So we have this interesting world where teams that wanted autonomy ended up creating software and architectures based on autonomy, independently deployable services, independently deployable components. Out of that, they created software, they created tools, they created technology that allows those teams to be autonomous and independent, which in turn makes the next generation of teams even more efficient in how autonomous they are. Got organizations like Netflix and Lyft and Slack, for example, all of whom have been using their examples Amazon to actually enable them to hit their next level of scale or level of autonomy or next level of speed. And this keeps coming out. All of those organizations have themselves then created more software that helps us. And it's a lovely virtuous circle we've got going on here. We should, though, start talking about some specifics. And here's where we get to one of the biggest problems with AWS. They haven't paid for my hotel room yet, so I'm going to sugarcoat it a little bit. But there's so much stuff. There's loads of stuff, right? This is a problem for me when I was doing those training courses. Every evening before a training course, I would have to go and check they hadn't launched anything. Subscribing to Jeff Barr's blog, oh, for God's sake, Jeff, what have you released now? And I'd have to go and re-screenshot something on my application, going, oh, they've changed all this, and then this has come out, which invalidated this whole section of content. It became exhausting keeping up. And when we have something like a microservice architecture that even putting the technology to one side has so many different options of how you can build them, when you bring in a huge product suite like AWS, there are so many different options in how you can bring that to bear. So what I want to do is give you a few examples of different ways in which you can use AWS to actually help implement a microservice architecture. This is by no means exhaustive, because if we try to go through all the options, it would be exhausting. But let's start with the basics. Let's start with the simplest thing that could possibly work, and let's actually start with some of the lowest level primitives that the AWS platform has provided us and has provided us for many years. We can start off with a single process. It's the My First service. I want to launch it. What's a really basic thing I could do? Well, here's it. I'm going to launch it and deploy it onto a single EC2 instance. Okay? So far, so good. Right? That's all I'm doing. One process, one instance, EC2 instance, that's fine, bit of compute. Never hurt anybody. I obviously want to store some state somewhere because my services are stateless. And by that I mean they actually hold state, but just somewhere else. So we could argue about that later. So I store that state somewhere else, and I love RDS. I've loved RDS since it came out. When someone finds a great abstraction, it just works really, really well. And RDS has saved my bacon so many times. So just a standard relational database, none of this sort of hippie NoSQL nonsense for us. Good old-fashioned relational database sitting there at RDS. Okay, so this is good, and RDS offers me some benefits. But of course, I have to recognize the fact that even if I have no load considerations of my service, that deploying a single node system on Amazon is problematic because we have no SLA for compute within an availability zone, right? So you have to deploy across all the availability zones to actually even get anything like the SLAs around compute. So that means I need a couple more nodes at least. Okay, I probably want to keep those nodes running, so I stick those things firstly across different availability zones to get that SLA, and I'll stick it in an auto-scaling group. Probably just one to keep it running. Okay, just keep the 3 nodes. I want 3 nodes and 3 different availability zones. That's fine. And I'm going to stick an ELB on top. Okay, this is a very, very simple, standard, vanilla, horizontally scaled microservice. And it looks really boring. And guess what? It probably works for 99% of the stuff you're going to do. So, that's good. But of course, this logically, what we're looking at here is the physical topology of a single logical service. But of course, you don't have one service, do you? Because if you had one service, that's not a service, is it? That's just a monolithic application. There's nothing, I'm not saying there's anything wrong with monolithic applications at all. They work really well for a large number of companies. But you're here to learn about microservices, so this is by itself not as much use. And then we start hitting some of the issues that emerge once you start doing these things at scale. So I've got, maybe I've got some scripts to manage this, and I should be automating this stuff. But then you start realizing, well, this is just one logical service amongst many. I've got multiple different, like almost templates of services, multiple different logical services that have to be deployed and managed. And they all might be variations on a theme. Some might have more nodes, some might have fewer. Some might have nodes that are more powerful than others. Some might not require a database backend. But they're all kind of variations on a theme, but they all need to be managed, almost like the cookie cutter in a way, just popping out new versions of these things. And so managing this stuff becomes a bit more problematic. And this is when we start reaching for, again, a higher order abstraction, or something that allows us to control these low-level primitives with something a higher order. So typically people start reaching for things like AWS CloudFormation. I personally prefer Terraform from HashiCorp, partly because I have just a visceral reaction to JSON. I think it's the devil's work. And you can't argue me out of it. There's no logic behind it. It just is. So I just move on with my life. I'm ambivalent about Vi versus Emacs, but when it comes to JSON, I have views. So no CloudFormation for us. But both of these tools are useful, right? They allow us to, in text form, effectively create templates that are going to deform the production, or say the deployment topology of our services. Those things can be parameterized. That's good, right? Okay, so that now allows us to very quickly spin up new clusters of our services as we need them. We can do better. Is there something higher? Is there a higher level abstraction we can work with? Again, higher level abstractions allow us to do more with the people we've got. It allows us to handle more moving parts. So what else have we got? Well, we've got Elastic Beanstalk, and Elastic Beanstalk's a bit of an interesting service. It's sort of, when it first came out, it was Amazon's, I suppose, real first attempt at a platform as a service. And here really it's very much more focused on the idea of running an application. Right, so straight away the concepts they talk about there as an application you have. So you've got a higher level, a higher order construct. You're not just talking about an EC2 instance that you then have to configure yourself. You're now saying, no, I have an application. How is that managed? And so Beanstalk has some nice things. It supports different runtimes, and it can do nice things for you, like say, okay, well, you want your application deployed this way in your development environment, and over here in QA, you want it in this way, and over here in production in a different way. So we've got a high level abstraction that starts talking more about the language of development and development of software, rather than wiring together operating primitives. This is sort of better. I think in practice, Beanstalk works really well when you're just getting started running something on AWS. I think if you're running one or two services, it's fine, but really it's more built, I think, for monolithic applications than service-based applications. Typically, when I speak to my clients, and certainly my own experiences, people start here, but will often then move on to something else. But if you're just moving on to Amazon for the first time, this might not be a bad place to look at. They are adding features to Beanstalk all the time, which allows you to stay with the platform for longer. But I think ultimately most people go beyond it, certainly for services-based setups. Okay, so we need to take a brief aside now and talk about containers, because this is, technically speaking, the container track. So we do need to talk about what they are and why they might be useful, and why they might be useful in the context of microservices. The first thing is an old colleague of mine, James Lewis, says that microservices are an architecture which buys you options. It gives you loads of options to do all kinds of crazy stuff. Right? It allows you, for example, to do things like vary technology that you use. We want teams to be autonomous and be able to develop and evolve independently from other people. We're communicating over service interfaces. Therefore, while we're working, we might make decisions to use different technologies because locally, that allows us to go faster. So I might have one team writing something in Java, a different team writing something in Ruby, and a third team maybe running something on C#, maybe .NET Core, which is all the rage at the moment, right? This is great. This allows locally, this is a local optimization. But this can become a global optimization problem because you start realizing, oh, I need a whole different tool chain for managing deployments of software here and here and here. So straight away, that becomes painful and actually increases the cost of having a polyglot environment. This is one area where containers or containerization can help. With containers, what you do is you have a uniform format of packaging. You can bundle up a running, effectively, a process and say, this is like a virtual machine. You say, this is my service. I don't really care what's running inside the service, but it has a uniform deployment model. The idea being it's like the containers in shipping containers. They have uniform connection points. When one of those container cranes or picks it up and drops it on a truck that can take containers, you don't care if there's a car in it or money in it or cocaine being smuggled across the border. You probably care about that last one. But but from a point of view of the crane operator, it's the same thing you're moving around. And containers give us that same unit of deployment to an extent. You don't care what's happening inside the box as much. That reduces, therefore, the cost of having multiple different technologies. Typically, this is where Dakka's done really well. It's given us a lovely tool chain around managing those containers. So Dakka is just a tool chain on top of the idea of containers that have been around actually for a very long time. This idea of the shipping container is something they use a lot. It's a bit of a lie. It's actually, they've reversed into that marketing terminology, really, because we were talking about containers for years, like Open Solaris zones and NetBSD jails before the shipping container was ever really thought of. But anyway, moving forward, there are other areas and other reasons why containers are useful in the context of microservices. Remember, we want independent deployability. That means we also need to avoid causing problems for other people when we do our deployments. Very early on, when you start deploying services for the first time, you're trying to keep your sort of management and overhead costs low. And so a very common pattern is to say, well, we'll just keep the same number of machines we had in the past, but we'll just deploy lots of services onto one machine. So you might do this with an application container, or just run lots of different processes on different ports on the same EC2 instance, for example. So I deploy my services and it's all fine, right? But then you start realizing there are certain places where these things can get in each other's way. For example, if someone had let me check in any code recently, I could quite easily have created a new version of your software which uses significantly more resources than it used to use, because that's my speciality, is making slow code slower and making fast code really slow. It's like an order of magnitude problem, right? So suddenly you've deployed a new version of your service and it's gobbling, it's eating all of the resources on the rest of your machines. And those other services that are running on that box are severely impacted and potentially might even be taken out. So this becomes an issue, like services start getting in each other's way. It's also hard to know who's in charge of the box, who owns the box, who configures that machine in an appropriate way. This becomes like a multi-tenant environment, but you almost want it to be a single-tenant environment. You want to own the whole machine as the person deploying it. The issue is that once you start This is why, actually, that most organizations that have been using microservices for a while move away from this model and move towards a model where they run services on their own isolated execution environment, giving it its own operating system stack, its own set of resources. Now, for some organizations that operate at sufficient scale, that might well mean one EC2 instance, one service. So at Netflix, it certainly used to be the case that virtually all of their running nodes were either 64 or 32 gig RAM EC2 instances, and they'd run just one process because they're running at sufficient volume that it's justifiable. For a lot of us, though, we don't have those kind of load concerns. And we realize it actually becomes quite expensive provisioning lots of machines for your services, especially when each of those services might not be using that many resources. This is where containers can become useful, because containers allow you to much, much more cost effectively pack isolated execution environments onto the same underlying hardware. Effectively, it's like much cheaper virtual machines. So you get loads more of these things packed onto the same operating environment. And this actually is why microservices and containers have been working really well together over the last several years, because it makes it much cheaper to isolate them from each other, which gives you a lot more autonomy in terms of how you handle deployment. So let's think about how we might make use of Docker then to manage containers, again, on our sort of familiar old EC2-based world. So here I would launch a large EC2 instance. And it's quite good, actually. If I launch a big EC2 instance, I get a lot more I/O out of it than I would with a smaller machine. I run a Docker engine, which is the process which is going to allow me to manage the containers on that box. And then I can use that to provision and deploy Docker images, which are my services. So I start creating images that represent my deployed services, and I'm using the Docker engine locally to deploy and manipulate those. It's a much more cost-effective world. So it's really great cost-effective isolation, and that gives that uniform deployment model. So this is really nice. This is a nice world to be. Really fast turnaround as well. These things provision very, very fast. You might wait for a couple of minutes for an EC2 instance to pop up. Containers should launch in a couple of seconds. So also from a developer feedback point of view and from a scaling point of view, that can be really beneficial. The problem is that this is a single node solution. This is one EC2 instance, and I'm managing that EC2 instance in one place. As I mentioned earlier, you've got to spread your compute load across all the availability zones in your region to actually be eligible for those SLAs. So a single node solution isn't going to cut it. So what we need to be able to do is manage containers over lots of underlying EC2 instances across my Amazon setup. And because I want to do things like say, look, well, I need 3 copies of the blue service, and I want them distributed so they're resilient. And I want like 4 copies of the purple service. And it's like, well, how do I make that stuff work? Now, early days with Docker, what people were doing was they were writing scripts on top of the low-level Docker processes. So they would actually go and run scripts that would go and actually shell into the boxes and run the Docker commands on each node to bring those things up into a state of being. There's all kinds of issues with that. It's quite a brittle process, and it also doesn't do what's called desired state management, because really you want some form of desired state management. You want to be able to say, no, I don't just want 3 services running on these 3 instances today. I want that forevermore until I tell you otherwise. I want you to maintain that state in case of something crashes. So the question then is, well, how can I manage containers over multiple machines? What are my options here? And this is where we get into the space of what's called container orchestration or container scheduling. So here in the context of AWS, we have Amazon ECS. So I mentioned earlier on that sort of Borg, which was Google's internal mechanism for running containers, that ethos and that mindset is what drove sort of the development of Kubernetes and the abstractions that Kubernetes now provides. So how Google sort of think about containers from a developer point of view became Kubernetes, and that's exactly what's happened with Amazon ECS. How Amazon think about containers internally has now kind of come out into what Amazon ECS is for us now. So this is a way of managing Docker containers over underlying EC2 instances, but giving you another higher level of abstraction. You see, as we're going through, we're going higher and higher up in our abstractions. It's a higher level of abstraction to allow you to deploy those applications over multiple machines. So we get a whole bunch of stuff that's quite useful. We get the Amazon Container Registry. So as part of the Docker tool chain, you need a thing called the image registry, which is where you store your Docker images. It's actually a really interesting piece of technology, but running them is a bit painful. And so quite a lot of people that use Docker will actually just use a hosted provider to use those instances themselves. In fact, you can just use a container registry without using the rest of ECS if you want to, and some people do. So you get that, so they run and manage that container registry for you. This is probably one of the coolest things about ECS. And this is a sad thing to say, it's sort of 9 o'clock in the morning on a Tuesday. One of the coolest things is identity and access management. Oh, doesn't it get you going? Oh yeah, we're going to talk about identity and access management. And it's a really dull subject, but it's one of the best things about the AWS stack is the amount of control it gives you over resources and who can do what. And I just talked about autonomy and doing what you want, so why is IAM important? Well, actually, because IAM gives you safety as well. Because you have IAM, you are able to let people do whatever they want in this other space. Without having the security of IAM, you'd have to be much more controlling over it. So these identity and access management rules are actually there at quite a deep level in ECS. And that's useful because then you can run an ECS cluster as a multi-tenant type situation. So you might have 10 different delivery teams, but they could all work off the same production ECS cluster. That makes it much more cost effective. But then you could use the identity and access management rule to control what teams can do what things within that cluster. And those are getting better all the time. You also get stuff like auto-scaling. And these sorts of platforms, these container orchestration platforms, almost have two levels of scaling. The first is, I need more containers. And the second is, I actually need more of the underlying machines in the cluster so that I can put more containers on them. And so ECS, you can do both. We get a service abstraction, so with Beanstalk, we had an application abstraction. With Amazon ECS, we start talking about service abstraction. So right there, the language is starting to go our way. Right? These are people thinking about people deploying services. There's also a bunch of other stuff that's got, like placement strategies. This is a very common thing. All the tools in this space will have some form of placement strategy. This is defining how your containers are distributed. So when you say, I want 10 of these, you can give hints to the platform that tell it how they should be spread around. So for example, a spread strategy would say, distribute these 10 nodes evenly across all of my nodes, all of my underlying instances. And that becomes really useful when what you're trying to do is load balance a service and ensure some improved resiliency. You also get things like bin packing, where you can say, look, I want 10 instances. I don't really care where they're running. Actually, just try and densely pack them. And then the underlying scheduling platform will say, well, look, I'm going to try and pack these as densely as possible to increase the utilization of the underlying machine. And that might allow you to actually turn off some of those underlying machines. So that would be a strategy which is much more about reducing your costs. And all of these platforms have these scheduling strategies, and they're right there in ECS as well. We also have the context of health checking. So ECS itself can see if your nodes are up, your containers are up. And of course, you need that, right? I sort of touched on this idea earlier of desired state management. These platforms, when you're running like 25 services, those services are running, say, 5 or 10 instances each. It becomes quite difficult to keep up on all of that. And one of the ways we simplify that world is we start talking about desired state management. We start pushing work into the platform and say, look, I want there to be 10 of these things. Your job is to make sure there's always 10 of these things. For the platform to be able to do that for you, it needs to have some sense of health checking. It needs to know, okay, that node is dead, I'm going to kill it and restart it. And so we've got that again inside ECS. So a higher abstraction, managing containers across multiple nodes, deep integration with IAM and other aspects of AWS, quite a nice product. This is also the space where Kubernetes plays. Now, Kubernetes is sort of in a different space in a way. The abstraction level is about the same, right? We're talking at the level of deploying and managing containers on different machines. The abstractions are subtly different. The Kubernetes abstractions are based on the Borg abstractions. Kubernetes has become very, very popular. One of the things that people like about Kubernetes is it gives you portability across vendors. I know that might be sacrilege. As I said, I haven't paid my hotel yet. But if you did want a multi-cloud strategy, Kubernetes allows you to target a Kubernetes install running here or here or here. Turns out a large amount of people run Kubernetes on Amazon. This could well be because they just prefer the abstractions. It might also be that maybe they need to run Kubernetes elsewhere, perhaps on their own physical premises, and want a uniform level of deployment. So that's what Kubernetes has got going for it, and a nice ecosystem around that platform. The flip side is a lot of people I know that are actually sticking with ECS and like ECS, even though they also like Kubernetes, they're using ECS on Amazon because they're already using AWS and they really like the control they get with the identity and access management. That at the moment, I think, is still the killer feature for ECS versus Kubernetes on AWS. Now, we should probably also touch on how Amazon and Kubernetes are working together at the moment. So some of you may have heard of a thing called the Cloud Native Computing Foundation. So CNCF, as it's called, is part of the Linux Foundation, and it's a body that's been pulled together to try and make it easier for people to build cloud native applications. And really what they do is they curate different products, and different open source products primarily. The idea being, say, look, let's take all these great products, these great open source products that are out there, and try and find ways to help these things operate together more effectively and efficiently. Rather than having to pull together 25 different things and find they don't all quite work in the same way, let's at least try and bring people together, share ideas from each other, and help things integrate and work together in an efficient and effective way. There are all kinds of products that fall, and projects that fall under the banner of the CNCF. We've got Kubernetes there in the top left. We've also got things like Prometheus in the monitoring space. Two tools I really like, and the idea isn't that there should be only one tool either. The idea is there could be more than one tool for the same job. So in this example here, we've got both Linkerd and Envoy, which are both types of service meshes. They're a really interesting type of product. So this thing's been doing really well. It's been doing some excellent work in terms of trying to extract lessons learned from this, and Amazon is now a part of the CNCF, along with Microsoft and Google and everybody else. And this is being driven, primarily because there are so many people using this stuff on Amazon, and Amazon are like, well, let's join the CNCF and make that as easy as possible. So I think Arun's going to talk a bit more about that when we do our Q&A. If you are interested, by the way, on running Kubernetes on AWS, there's a bunch of products out there, projects out there that help you, things like COPS, and Arun's also put together a workshop, and you can find details here. And I think they're running some events at reInvent. I doubt you're going to get in, but you could try. But they're being one at the moment, talking all about how you run Kubernetes on AWS. There's some great resources out there. So you kind of get to have your cake and eat it in that world. You could do ECS as well, but that'd be kind of crazy. For me, it's like an either-or situation if you're on the AWS platform. Now, of course, how far? We're 40 minutes into this presentation, and so far I haven't mentioned the bigger elephant in the room. And I know we're on a containers track, but so this is a bit edgy talking about it. We should probably just talk about it, rip the plaster off and talk about serverless. Now, again, on serverless, I have views. There are some people that talk about what serverless is, and I just go back to the original definition, which, as far as we can tell, the first person that talked about serverless was Ken From back in 2012. That date's important. And here's sort of what he was trying to talk about, a sort of a new type of product that he was seeing that actually, again, higher abstraction, that removed the concept of a server from the vocab, that developers no longer need to worry about servers. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think that much about them. That's what all abstractions are about, hiding detail from us that we don't need to care about, right? And he was reflecting on the fact that there are new products that give us this stuff. The reason I raise this is a lot of people like to say, serverless, that just means function as a service, that just means Lambda. No, Lambda was announced in 2014. The term serverless was around for at least 2 years earlier than that. A serverless product is anything where you are abstracted away from the underlying servers being used. So Lambda is definitely a type of serverless product. It absolutely is, and it's a fantastic example of one, but there are others out there, and there are others in the AWS product suite that give us that higher level abstraction. We've got things like DynamoDB, and one could argue the mother and father of all serverless products on AWS of Amazon S3. Your low to zero management cost. I'm not worried about my servers. I'm only priced based on usage. Fits the bill for what serverless is. So let's talk about how I might use serverless, though, in the context of microservices, and specifically how I would use something like Lambda to build a microservice architecture. And this is pretty straightforward. As I say, most of the time, we're taking an API call in and maybe getting something out of a database and doing something with it, and then sending some information back out. And that covers like 70% of what you're going to do. We can make it sexier. We can write books about it, but really it comes down to that, right? Get a request, get something out of a database, do something else. Turns out Lambda fits really well for that, right? So, I'd have an API gateway, so the API gateway is needed to take an inbound request and launch an invocation of a Lambda function. So that function will be invoked when the call comes in, and it will live for the lifetime of that request up to a cap of 5 minutes, I believe, is the current limit. It used to be 1, now it's 5. And the nice thing is I automatically spin up a function instance when requests come in. So I'm not worried about trying to define my scaling rules, not trying to, how many machines do I spin up at what time or what load? No, it's very easy. Request comes in, function launched. So already my scaling abstractions become much simpler. And that's nice, that's great. Obviously, if I can still go and get things from a database. Now, a database is not a function, it's a thing that's stateful. I go and fetch information from that, and the world is good. Of course, you do sort of start getting some interesting problems here. Especially when you have these sort of hybrid architectures where you've got some serverless, some not serverless. The scaling at the function level is mostly unbound. A request comes in, you launch an invocation, you're captured at like about 1,000, you're captured 1,000 instances or whatever. But we're used to, with normal applications, to be able to find other points in our architecture to throttle our load and reduce load in other parts of our system. With a serverless architecture like this, where our front door is sort of unbounded in terms of how it scales, we can start having impedance mismatches between the functions and the backend stateful services. For example, the load comes in, and as the functions keep getting spun up, that can create enough load on my backend database, say a traditional RDS instance, to take that instance out. And that could be quite problematic. This does actually happen. There's an organization called Bustle who make heavy use of AWS serverless stuff. They run about 60 million uniques a month here in the US. They're a media company. They're talked about as being all serverless, but they're not. They actually use Redis as a database in the back end, and putting aside any concerns you might have about running Redis as a database, it works for them. Although they had this problem. As the load came in, more functions were launched. Those functions caused sufficient load on their back-end databases to take those databases out. So the hybrid world gets kind of interesting because we've lost those things like database connection pools to manage that load. And of course, the solution is to then look at something like DynamoDB, which again, as a service back-end, as a service, should hopefully scale with that load. This does leave me with a bit of a puzzle because I really like serverless stuff. But typically when I'm working with customers and clients, we're looking at how do we incrementally adopt new technology. And this does leave me with a few puzzles of how do I incrementally move to a serverless architecture when parts of my system don't have the same elasticity. I almost think we might start looking at things like service meshes to act as intermediary layers between ephemeral functions and stateful backends to manage the performance of those systems. But now, typically when I'm just sitting down, especially with a blank sheet of paper, I'm often thinking, how can I push as much of this stuff into the platform as possible? And ultimately, that's using these higher abstractions like serverless. Should also mention, of course, with serverless, another thing we like is if there's no request coming in, there's no function running, that's great from a cost and a security point of view. So serverless functions can be cost effective because you should only pay for what you use. Same for backends as a service, you're only charged based on your storage and your ingress and egress. That can also make calculation of running costs difficult. And I do know some people that have struggled with talking about serverless architecture implementations purely because they couldn't work out what their costs were going to be, their running costs. And they've stuck with good old-fashioned EC2 instances because at least they get predictable costs from it, even though they accept those costs might be higher. But they can be much, much cheaper to run, but they will be uncertain. They can also be more secure. These are typically highly sandboxed products. High-level abstractions often can give you some security benefits. Things like the functions aren't running if they aren't being invoked. I think it's a better abstraction for most developers. I think this is the thing, like we've been building these applications for longer. We've got better at working out what it is that our developers need to be able to build systems more effectively. I sort of look back now at infrastructure as a service and feel that those are not really, when you look at it now, that isn't really a developer-friendly abstraction. That's actually like a Savi ops-friendly abstraction. I think this is starting to get closer to developer-friendly abstractions on the AWS platform. So when you think about serverless, just think about this as a better developer-friendly abstractions. I think we're getting closer to what we need, what most developers need to be able to build applications. And it's no surprise you're now seeing function as a service implementations that run outside of the cloud vendors. If you want to Google it, you'll probably find a new Kubernetes framework every 10 minutes being launched to run functions as a service on that particular platform. I joke, but I did this for a talk recently. I Googled it and I found 7 different implementations that all had lots of styles on GitHubs, and it was all very confusing. But they are out there, right? Because the idea is really good, right? Although, Lambda, you could argue when it was first launched, was much more about gluing different Amazon products together. When it comes to service developers, it's really useful. It's also worth noting, talking about abstractions, that certainly the functions of service stuff, it's a wrapper over containers. We know there are containers under there. You just don't need to worry about them anymore. This is why, I think containers are incredibly important and also something that most of you should know nothing about probably in the next couple of years. They will increasingly become an incredibly useful implementation detail of higher order abstractions. So right now, everyone's running around going Docker, 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 and it's fantastic. No one's going to care in a few years because it's going to be hidden from you. And the fast stuff is just the first example of that happening. So hopefully I've tried to sort of create a picture for you. I mean, it isn't just to say that there are lots of options for microservices using the AWS platform, but more that the mindset of the AWS platform itself was driven by an organization that wanted to increase the autonomy of their teams, make it easier for people to develop software. And so almost the ethos of the AWS platform is built with that in mind. And that's why these things go really well together. Yes, it is very, very daunting to all of you because there's so many different options. My general advice now for companies that are starting off with Amazon and microservices, if you've got something really, really simple, I would just start off with Beanstalk initially, see how that goes. I think you will outgrow it. And if you start getting to a certain level of complexity, then you're going to want to start looking at something like ECS or maybe Kubernetes if you have to deploy elsewhere. I probably wouldn't be starting with putting together an EC2 instance and an ELB anymore. Right, that for me is already a lower level abstraction that you don't need to worry about. But if you can start Dockerizing your application, it'll make it easier for Beanstalk, it'll make it easier for ECS and elsewhere as well. Thank you so much for your time. I think we're going to do a bit of a Q&A now. You ready?
Yeah, we can do that.
Yeah.
Am I live? Yeah, cool, awesome. Thank you. That was a fantastic talk, actually, really enlightening. Now, so I truly feel like a kid in a candy store. There is containers, there is serverless. In containers, there are so many ways by which I can do containers. Or containers are required necessity or an evil necessity for microservices. I want to talk a little bit about that. So tell us, I'm a customer of AWS, and I'm running a monolith on a classical AWS environment, and we're looking to migrate to microservices. I go in a store, what am I looking, what am I picking? Yeah. That makes sense for me.
I mean, you've got a whole bunch of questions, which is what's the first thing you extract, and there's stuff in the book about that. That's more the non-AWS specific. I probably would nowadays, especially on Amazon, I would say, okay, I'm going to put out this functionality into a new service. I would be looking to containerize it as I did that move. If I containerize it, it's going to make it easy for me it's got an artifact deployment, make it easy for me to run locally, make it easier on AWS, makes it easy to run on Beanstalk, runs on ECS. So even if I just containerize it, I still open up a whole load of options and give myself that nice, easy, uniform form of deployment. And so I'd at least get to that point. And then you still have the choice of, a Beanstalk, managing your own Docker engine, ECS or Kube.
Right, so the key part being, take a look at your existing monoliths, rip them apart per the principles that are given in your book, and then once you have identified the different services, containerize them, and then look to the next path.
Yeah, I think the one sort of exception I'd say there is if you're already all in on AWS and you don't have to be on other platforms, is I probably would also be looking at, when I come out, it's like this thing is, could it be a function? Could I just embrace Lambda? Now, I think there are still some gotchas around that. There's still some interesting things about observability of those platforms. But increasingly, I'm looking for opportunities to make heavy use of Lambda, just because the drastic reduction in my maintenance costs, not setting aside the money I pay you guys to run lovely events like this, it's actually just the maintenance and the admin costs are much lower as well.
Yeah, absolutely. So I think that makes complete sense. Now, you can made a good point about serverless versus containers per se. But if I'm looking with the containers landscape itself, is containers a real necessity for doing microservices? I've made a huge investment building my monoliths on EC2 instances.
Yeah, it's not required. I think it's typically a scale play. I think once you get to a certain number of these things, containers become a worthwhile investment because they reduce the cost of managing these things. And so for me, if you've got a thing that works right now, there's no reason to switch to it. I would look to switch when you start having a large number of moving parts, because then you can start making use of platforms like ECS and like Kubernetes that can manage those containers at scale.
Got it. Now, you had a question for me as well.
Well, yeah, so the thing I was interested in is, I know it's give you a hard time, it took you a long time to join the CNCF. So I'm really interested as to what you see the role of Amazon, because obviously people see, I think simplistically see the CNCF, the Cloud Native Computing Foundation, as just Kubernetes, which is not. It's only one of the things it does. And of course, Amazon has ECS as well. And so I was really interested as to, because I know what is the role of Amazon on the CNCF, what's it there to do, and what's it trying to achieve as part of being a member?
Yeah, totally. Well, if you think about, when Netflix started open sourcing, so Amazon has been helping customers building cloud native applications for many, many years. This term cloud native, if you think about it, kind of became a fad 2 years ago, and that's when the CNCF essentially was funded. So we have been helping our customers all along building those cloud native applications. Yes, it took us a long time. I just barely joined Amazon this year, so I took it on me personally. And since then, we have joined CNCF. We are a platinum member. That gives us a seat at the board. So we're definitely looking forward to, we are continuing to participate very actively in the CNCF different activities. As we talked about the Kubernetes on AWS workshop, if you look at the CNCF survey, and a lot of our features, product roadmaps are heavily driven by customer obsession, essentially. So if you look at the CNCF survey, about 2/3 of Kubernetes today runs on AWS. That's the reason we built that workshop essentially completely out in the open source. It's a GitHub repo essentially. Anybody can contribute a feature, a pull request, whatever you want to do. And then not just Kubernetes, but we are looking at a whole variety of projects across the CNCF ecosystem essentially on, like literally this morning, somebody sent a pull request. How do you use Jaeger with Kubernetes on AWS?
Right.
We have like Linkerd and Kubernetes on AWS. We got like Envoy on Kubernetes on AWS. So we're looking at the entire CNCF landscape. We definitely want to contribute more actively to Kubernetes upstream.
Yep.
Make sure that experience for our customers stay absolutely relevant.
And you should go check out the workshop.
This is the workshop, yeah. It is now in a AWS blessed repo. I know I started this in my personal handle, but now it's an AWS blessed repo, but it'll automatically be redirected to the right link for you guys.
Cool. I think if you haven't got anything else, I'll take a couple of questions from the crowd, maybe?
Yeah, well, go for it.
Yeah. Just say thank you much for Arun for inviting me and paying for my flight. I think he's paid for my flight. Anyway, I'll take a couple of questions. I'm going to hang around after anyway, but I'll take a couple of questions before we run out of time. So I think you've had your arm up for a while there, so go ahead.
Yeah. So you got almost to it in your slides there, but imagine we have serverless setup. We want to use an RDS Postgres database.
Yeah.
10 functions, and now I have 10 fresh connections on startup to that database.
Yeah.
What do you guys got for solutions?
Well, it's actually a bit worse than that. So there are, because we know that functions get pre-warmed to reduce spin-up time. The Bustle team actually found some really interesting stuff, which was that their Redis instances were topping out at 10,000 connections. You can't have 10,000 functions running. Unfortunately, I don't have any great answers for you right now. So I don't work for Amazon, so as well, so to be really clear. So I'm being really honest. I'd say, so what they were doing, they were actually doing stuff on the Redis instances themselves around stuff with the TCP stack. They were killing idle connections and things to throw those old connections away. There was actually a number of connections rather than the load problem. Now, I think I could probably solve this with a service mesh, but I haven't done it, and I want to talk to the teams at Linkerd. I know both the teams at Linkerd and at the Istio lot, because I think that could be a solution. So service mesh, for people that don't know, imagine it's like middleware for synchronous calls. It's a bit of a simplification. But it's basically when I talk from one service to another, I go via the service mesh. The service mesh can handle routing, traffic shaping, tracing, and logging. And so one of the things that could actually be where effectively our connection pooling that used to be inside could start sitting in those service meshes. Now, this is a theoretical idea that I've started talking to some people about. I would also imagine that we will start getting some controls around these things. I mean, the answer at the moment is you just need to scale the stuff up way in advance of what your functions might be, and potentially also try and, because you can actually also constrain things. I think I'm right in saying you have more control over controlling invocations at the API gateway level than you do at the Lambda level. So that would be the other thing you can do, would be to constrain it at the API gateway. I think these things will get better, but I do wonder if the service meshes might solve it, and I've got outbound requests, so there might be a blog post too. Cool. I'll do a question over here, and then we'll do one over here. So a question over here. Hi. Yes. Well, so typically when you're trying to compose, so you might need to I might need 5 or 6 different things in order to carry out an operation. Sometimes you might end up with a service which itself is that composition. So I might have a metadata service which actually pulls information from my listing service and everything else. It gives me those high-level abstractions. That's quite a common pattern. They do specifically with Amazon, but that just becomes like a higher-order service in a way that pulls those things together. You also have a situation where you sometimes need to have multiple services work together to carry out some kind of operation, afterwards like a business process that might require multiple different services to be involved. And there typically we start talking about 2 different core approaches. The first is what's called orchestration, where you have a central process manager that has effectively a representation of your business workflow. You might be able to do like the simple workflow manager from Amazon for that. I haven't tried it myself. That's traditionally where a business process modeling tool would be used. I personally prefer an approach called Choreography, where you basically have, you make heavy use of events, and services react to events and understand what they need to do. So you don't have to read my book, but if you go to the Safari bookshelf, you can sign up for a 30-day free trial. If you go to, there's a section called Orchestration versus Choreography. It works very much by itself. You can read that little section by itself, all for free. And I sort of outline the 2 different approaches, choreography and orchestration, and how you make those 2 worlds work. The other thing that might be of use is I did an article on things called backends for front ends, which can work where you need to aggregate lots of calls for user interface requirements. So if you search for Sam Newman BFF, you don't become my best friend forever, but you do get the article about backends for front ends.
All right, I think that's about our last question.
Yes.
If you have any more questions, we're going to be hanging out in the hallway. Come please talk to us over there. Thank you so much.
Thank you so much for your time.